Okay, so I wanted to make this short video to teach you a very simple trick of graphing inverse functions. Now, this might not be very useful if you're just doing the parent function because you probably know the parent functions, but if you're working with transformations, you can find the original function. Sometimes it's easier to find the original function because we know how to graph those functions easily, and then we just flip the x, y values, and we can get our inverse functions there. What do I mean? Well, recall that inverse functions, they're symmetrical around y equals x, right? So we're going to take our example, which is x cubed. The inverse of that is the cube root of x. So if we draw this out, notice how this x, they're symmetrical. They're just reflected over that line, right? Now, secondly, let's say you're given the cube root of x, right? You have to graph that, but you don't know. So what you can do is you can take the x cubed, you take all the values there, all the xy values, and you just swap them around, and then you get your function. Let's say 1 is not really good because it's the same. We have 2 and 8, right? Now, what do we do now? Well, on our inverse function, we can just graph 8 and 2, just like that. So if we combine this with the fact that we can use mapping notation for our parent function, we can actually make it so that we can graph our parent function really quickly, and then we can just switch around the xy values and we get our inverse functions, just like that. This is just a really powerful and simple trick of the definition of inverse functions. And this applies to graphing as well. So now you should be able to graph basically everything at this point, just with these tips, these tricks, and the inverse function and mapping notation. I'll see you in the next video.